Hello everyone, welcome you all to online session. I am Prerana Shinde from the Department of Chemistry, S.V.K.T College, Development Camp, Nasik. So today we are going to see about the modern periodic table. In that we are going to see the Mendeleev's periodic law, the periodic properties, the division of modern periodic table on the basis of S, P and D, F block and their periodic trends, atomic size, atomic radii, their screening effect, again the ionization energy, electronegativity. These are some trends in the modern periodic table. So the Mendeleev's law states that the properties of elements are the periodic functions of their atomic number. Basically the modern periodic table based on the atomic number or the increasing atomic number is also known as the Mendeleev's law. Is also state that the chemical and physical properties of the element recur periodically when the elements are arranged in order of their increasing atomic weights. This is a picture of the Mendeleev. How the periodic table get classified? The elements are broadly divided into basically the metal, non-metal, semi-metals are metallites. The semi-metal exhibit the property of intermediate between those, the metals and non-metals. Metals are located on the left of the periodic table, non-metals located on the upper right. They are separated by the diagonal band of a semi-metal. Here is the picture which shows the modern periodic table. The first and second group is the alkaline earth metal, basically consisted in the S block. Why the S block? Because according to the electronic configuration, according to atomic number, the electronic configuration bifurcated into, or the last or valence electron get into the S block. Therefore, they are a S block element. The first row or the first column is the hydrogen, lithium, sodium, potassium, rubidium, cesium and francium, the alkali metal. Next is the alkaline earth metal. Here the pink color shows the S block. Again to the right hand of the periodic table, that is a boron, carbon, nitrogen, oxygen, fluorine and helium. These are the 6 families: boron family, carbon family, nitrogen family, oxygen family, also known as the chalcogens. The halogens, fluorine, chlorine, bromine, iodine, acetine, these are the halogens, and to the last of the periodic table these are what the inert gases or the noble gas element, because they have a completely filled electronic configuration, completely filled octet they have: helium, neon, argon, krypton, xenon, radon. These are the noble gas element. In between these two, that is S and P block, there is a D block, D transition element. From the atomic number 21 to 30, that is scandium to zinc, these are the D block elements. To the bottom of the periodic table there are F block element. As their electron goes to the F orbital, these are the F block elements. From the lanthanum to lutetium, there is a lanthanide series and actinide series to the last, that is actinide to the lawrencium. These are basically a radioactive element. Some of them are naturally occurring radioactive element and some are the prepared, or the in a lab we are going to prepare that. So this is all about general information about the periodic table. In a boron, aluminum, gallium, indium, thallium. In a boron family, aluminum, gallium, indium. In a carbon family, silicon, germany and tin. These are basically a metallites, which shows the properties of metal and non-metals. To the right hand of the periodic table, these are the non-metal. To the left, these are the metal. So how the classification of the elements on the basis of S and P block is there? The S block consists of the first two group of the periodic table. The S block emitters are either alkali metals or alkaline earth metal. The first column, first group or first column, and second group and second column is what the alkali or alkaline earth metal. And they form the alkali. For example, sodium hydroxide, potassium hydroxide, they form the alkali. They are soft, have a low melting points, they are electropositive and chemically active metals. Basically, In a periodic table we can see to the left hand side they are the electropositive metal, as they have a only one electron is there into their valential electronic configuration. So, they have tendency to lose the electron and get stabilized. Therefore, they are electropositive metal. P block consists of the last 6 element groups of the periodic table excluding the helium. The P block elements include all of the non-metal except hydrogen and helium, the semi-metal and the post-transition metal. The P block elements are carbon, nitrogen, oxygen, sulfur, halogens. Mostly they form the covalent compound, and carbon is the non-metal which is very used to in our chemistry, in our daily chemistry. So, this is all about the S and P block. P block generally shows the losing, gaining and sharing of their valence electron. So, mostly they are the electronegative. As we are going from left to right, the electronegativity of the elements get increases. The next is the D block. D block elements are the transition elements from the 3 to 12, from the group 3 to 12. They have a valence electron in their last 2 outermost shell. D block elements behave in a manner that is somewhere between that highly reactive electropositive alkali metal and the covalent compound forming elements. They have generally high melting and boiling point, typically form the colored salt. As they show the DD transition, like your manganese, K-4, K2Cr2O7, in that you used chromium, which shows the colored components. They act as generally a good catalyst. So, this is all about the D block elements. In a F block are the inert transition elements, usually the lanthanide and actinide series, also known as the lanthanum and actinum. These elements are the metal, radioactive metal, and the high melting point. They show the variable oxidation state up to the +3, +4, and they also form the colored salts. So, next we are going to see the periodic trains, that is all about the atomic radius, ionization energy, electron affinity and the electron affinity, their metallic character. So, how in the periodic table these trains get followed from left to right. What is the atomic radii? Generally, it decreases from left to right along the main group element because the nuclear charge increases but the outer electrons are still in the same shell. However, going down a column, the radii generally increases because the outermost electron in a higher shell, that does the further away from the nucleus. In the transition element, an inner shell is filling, but the size of an atom is still determined by the outermost electron. The increasing nuclear charge across the series and increase the number of inner electron for a shielding somewhat compensate each other. So, the decrease in radius is smaller. As we go into the periodic table, you can see as we go from left to right, that is from the lithium to neon or the sodium to argon, the atomic radii get decreases from left to right and increases from top to bottom. As the number of electrons get added into the same shell, therefore, the attraction between the outermost shell electron and from the nucleus and from the centimeter atom or from the electron which is in the 1s orbital, there is an attraction between increases. So, therefore, the shielding get increases and because of that the atomic radius gets shrink. So, as you go from left to right, the atomic radius get decreases as the screening effect get increases as because of the number of electron added into the same shell of that outermost electron. So, this is all about what the atomic radius. The trend get followed like as you go from left to right, the atomic radius get decreases. As you go from top to bottom, the atomic radius get increases. Next is what the ionization energy. The ionization energy is the minimum amount of energy required to remove an electron from the outermost orbital. If you have taken the example of nitrogen, nitrogen has the electronic configuration 1s2, 2s2, 2p3 as it has a atomic number 7. So, in a last shell there are 3 number of electron. To remove an electron, how much amount of energy will required, that is called as a ionization energy. Generally for the full-filled electronic configuration, that is 2p6, and half-filled electronic configuration, that is a 2p3, the large number of energy required to remove the outermost electron. So, if you have taken the example of carbon, that is 1s2, 2s2, 2p4. Like a carbon and nitrogen, if you have taken the example of a carbon and nitrogen, carbon will require less amount of ionization energy to remove an outermost electron, but as the nitrogen has a half-filled electronic configuration, it will require the higher ionization energy. So, this varies with the atomic radius. Ionization energy increases left to right and down to up, because electrons that are closer to the nucleus are held more tightly and more difficult to remove. So, this is all about the ionization energy. Next is the electron affinity. This is the opposite property to the ionization energy, is the electron affinity, which is the energy released when adding an electron to the atom. A passing electron will be more readily attracted to an atom if it feels the pull of a nucleus from strongly, and especially if there is the available partially filled outer orbital that can accommodate it. Therefore, electron affinity tends to increase down to up and left to right. That is, electron affinity increases down to up and left to right. The exception is the last column, that is a noble gas, which have a full shell and have no room for another electron. This gives halogen in the next to last column the highest electron affinity. As the halogens are also known as the inert element or the zero group element, they have no rooms, they have no extra shell, so that we can add the extra electron into that. Therefore, the halogens show the least tendency, or the electronegative electron affinity tends get vanish in case of a halogen. Next is what the electronegativity. Electronegativity depends upon the how strongly the nucleus can attract an electron pair. So, it exhibits a similar variation to the other property already discussed, that is the your ionization energy, atomic radii. The electronegativity tends to fall going to up and down, rise going from left to right. As you goes from sodium to fluorine, the fluorine has the highest electronegative value in the periodic table. The alkali and alkaline earth metals are among the most electropositive element, while the chalcogens, that is the oxygen family, halogens, that is the fluorine, chlorine, bromine, iodine and acetine, and the noble gases, that is the helium, neon, argon, krypton, xenon, are among the most electronegative one. So, you can remember it as we go from left to right, the electronegativity get increases. As you goes from the left to right, the atomic radius get decreases. So, these are the basic trends in periodic properties. Here you can also discuss with the periodic table that here is the hydrogen family, beryllium family, boron family, carbon family, nitrogen family, oxygen, halogens and the inert gases. So, as you go from the sodium to chlorine or to the inert, the electronegativity value get increase, the atomic radius get decreases. Also, the first and second group contains the alkaline and alkaline earth metal. The boron, carbon, nitrogen, oxygen, fluorine, that is from group 3rd A to 7A. There are the elements are included into p blocks, because as you write the electronic configuration, the outermost electron goes into the p orbital. The first and second group, they are the s block elements. The middle of these two is the d block, as they show the colored compounds are due to the various oxidation states, they show the colored compounds. To the bottom of periodic table, there are two series, that is a lanthanide series and actinide series. These are the radioactive elements located in the F block elements. So, this is all about the periodic table, that is a general description of the periodic table, on what the periodic table is based, how the classification of S and P block is, SP D and F block is there. Atomic radius, ionization energy, electron affinity and electronegativity. These are the 4, and there are much more trends in the periodic table and how they get followed from left to right and top to bottom. So this is all about today. In the next lecture we are going to some more properties of periodic table and how to write the electronic configuration. Thank you.